Dear student, welcome to our pre-calculus class. Today, I will discuss how to find the equation of the exponential function in the form f of x equals a times b to the power of x plus k when we have values of x and f of x from a table. So the first, how to identify the base b. So b is our base. So we're going to subtract the values of f of x. So 8 minus 5 is equal to 3. 14 minus 8 is equal to 6. And 26 minus 14 is 12. So now we're noticing that every number can be, when multiplied by 2, we'll get the next value. So here 3 times 2 is 6. 6 times 2 is 12. So now we found our base. Our base is equal to 2. So we have some idea how the function will look like. A 2 to the power of x plus k. Now we're gonna take any 2 points from the table, 1 x, 1 y, and for example 0 and 5, then another x and another y, 1 and 8. We usually want to work with smaller numbers, so our coordinates will be 0, 5, and 1, 8. So one is x, the other one is f of x. X, f of x. So now we're going to create a system of 2 linear equations in 2 variables that will help us find the values of a and k. Okay, let's see. F of 0, because x is 0, will be a 2 to the power of 0 plus k. Now 2 to the power of 0 is 1, so a plus k will be 5. F of x is 5 when x is 0. Now the second one, f of 1, a 2 to the power of 1 this time, plus k, will give us 2a plus k, and that one is equal to 8. Now, this is the system that we're gonna work with. Okay, so we have 2a plus k equals 8. Now remember, we want opposite coefficients in front of one of the variables, so we can work with the elimination or addition method. So I'm going to multiply with -1 the second equation. So it's a plus k equals 5. But I'm going to multiply the whole equation by -1. So I can get opposite coefficients in front of k. So this becomes 2a plus k equals 8. It doesn't change. The second one becomes -a minus k equals -5. Now I'm ready to add them up. 2a minus a equals a. K minus k is 0. And 8 minus 5 is 3. So now we have our coefficient a. And you can use any of the previous equations to find k. So for example, a plus k is easy to choose, equals 5. And then if we substitute a with 3, we can see that our k is 2. Now we're ready to build up our function. F of x equals 3 times 2 to the power of x plus 2. And that is our final answer. I will solve one more example. I have another table. I will repeat absolutely the same steps. So find the equation of the exponential function in the form f of x equals a times b to the power of x plus k from the table below. So this is the expression for f of x. So let's subtract. 17 minus 9 is 8. 41 minus 17, 24. And 113 minus 41 will give us 72. Now, we can see, if you're not sure, you can always divide 24 by 8 and 72 by 24. And if you get the same ratio, if we have the same answer, so we can see that here, if we times by 3, we'll get the next number. So 8 times 3 is 24. 24 times 3 is 72. So the ratio for these two is 3. So this is our base. Okay, base is found. Now we're going to choose 2 points from the table with x and y values. 0, 9, 1, 17. So f of x equals a 3 to the power of x plus k. All right, let's substitute. F of 0 will be a times 3 to the power of 0 plus k. Again, any number to the 0 power is 1. So a plus k equals 9. F of 1 will be a 3 to the power of 1 plus k equals 3a plus k equals 17. Okay, we have our system of 2 linear equations in 2 variables. Again, I will write 3a plus k first equals 17. And then I will write a plus k equals 9. We want opposite coefficients in front of one of the variables, so I'm going to multiply this by -1. The first one will stay the same, 3a plus k equals 17. Now the second one changes. The second one changes to -a minus k equals -9. Now we're ready to add them up. 3a minus a, that's 2a. K minus k is gone. And 17 minus 9 is 8. Now we're dividing by 2. So a is 4. So we found a equals 4. Now it's easy to substitute in from the equation a plus k equals 9. All right, if a is 4, obviously k will be 5. 4 plus 5 is 9. Okay, here we go. Our function is ready. f of x equals 4, 3 to the power of x plus 5. And this is our final answer. I hope this video was helpful, and I look forward to seeing your work in class. Bye.